Top 25 computer science interview questions and answers. Computer science interviews test both theoretical foundations and practical problem-solving skills. Candidates are expected to demonstrate knowledge of data structures, algorithms, operating systems, databases, networking, and software engineering principles. Interviewers often evaluate logical thinking, coding ability, and understanding of real-world applications. Strong communication skills are equally important, as explaining complex technical concepts clearly reflects depth of knowledge. Preparing structured answers to common questions helps build confidence and clarity. Below are the top 25 computer science interview questions with concise, 90-word answers designed to help you prepare effectively and perform confidently in technical interviews. 1. What is computer science? Computer science is the study of computation, algorithms, data structures, and software systems. It involves understanding how computers process information and how problems can be solved efficiently using programming and logical reasoning. The field covers theoretical areas such as computational complexity and practical areas like software development, artificial intelligence, networking, and cybersecurity. Computer science also focuses on designing scalable systems, optimizing performance, and ensuring data security. It integrates mathematics, logic, and engineering principles to build innovative technological solutions that power modern industries and everyday digital experiences. 2. What is a data structure? A data structure is a way of organizing and storing data so it can be accessed and modified efficiently. Common data structures include arrays, linked lists, stacks, queues, trees, and graphs. Each structure has specific advantages depending on the use case. For example, arrays allow fast indexing, while linked lists enable dynamic memory allocation. Choosing the right data structure improves performance and reduces time complexity. Efficient data structures are critical in algorithm design, database indexing, operating systems, and software development to ensure optimal resource utilization and speed. 3. What is an algorithm? An algorithm is a step-by-step procedure used to solve a problem or perform a computation. It takes input, processes it through defined steps, and produces output. Algorithms must be finite, well-defined, and efficient. Their performance is measured using time and space complexity. Common algorithm types include sorting, searching, recursion, and dynamic programming. Efficient algorithms are crucial for scalable systems, especially when handling large data sets. Designing optimal algorithms requires logical thinking, mathematical understanding, and knowledge of data structures to ensure accurate and fast problem solving. 4. Explain time complexity. Time complexity measures how an algorithm's execution time increases with input size. It is expressed using big O notation, such as O1, O log n, and O in superscript 2. Big O describes the worst-case scenario performance. For example, linear search has O in complexity, while binary search has O log n. Understanding time complexity helps developers compare algorithms and choose the most efficient one. It plays a critical role in system performance, scalability, and optimization, especially when working with large datasets or high-traffic applications. 5. What is space complexity? Space complexity refers to the amount of memory an algorithm requires relative to input size. It includes both auxiliary space and input space. Efficient memory usage is important for performance optimization, especially in systems with limited resources. Recursive algorithms may consume additional stack memory, increasing space complexity. Developers analyze space complexity using big O notation to estimate memory growth. Balancing time and space complexity is essential, as sometimes faster algorithms require more memory. Understanding memory management improves system stability and scalability. 6. What is object-oriented programming, OOP? Object-oriented programming is a programming paradigm based on objects that contain data and methods. OOP focuses on 4 main principles: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation hides internal data. Abstraction simplifies complexity, Inheritance promotes code reuse, and polymorphism allows flexibility. OOP improves modularity, maintainability, and scalability of software systems. Languages like Java, C++, and Python support OOP concepts. It is widely used in application development because it models real-world entities effectively and reduces code duplication through reusable components. 7. What is a database? A database is an organized collection of structured data stored electronically. It allows efficient data storage, retrieval, and management. Databases are managed by database management systems, DBMS, such as MySQL or PostgreSQL. They support operations like insert, update, delete, and query using SQL. Databases ensure data integrity, security, and consistency through constraints and transactions. They are essential for applications like banking systems, e-commerce platforms, and enterprise software. Proper database design improves performance and prevents redundancy. 8. What is an operating system? An operating system, OS, is system software that manages computer hardware and software resources. It acts as an interface between users and hardware. The OS handles process management, memory management, file systems, and device control. Examples include Windows, Linux, and Mac OS. It ensures efficient multitasking, security, and resource allocation. Without an OS, applications cannot function properly. Operating systems play a critical role in ensuring system stability, performance optimization, and user-friendly interaction with computing devices. 9. What is a process and a thread? A process is an independent program in execution with its own memory space. A thread is a lightweight unit of execution within a process that shares resources with other threads. Processes are isolated, while threads communicate easily. Multithreading improves performance by executing tasks concurrently. However, it requires synchronization to avoid race conditions. Threads consume fewer resources compared to processes. Understanding processes and threads is essential for developing efficient multitasking and high-performance applications. 10. What is networking in computer science? Networking refers to connecting computers and devices to share data and resources. It involves protocols like TCP/IP that define communication rules. Networks can be LAN, WAN, or MAN depending on coverage. Networking enables internet access, file sharing, cloud computing, and communication services. Key components include routers, switches, and servers. Understanding networking fundamentals helps in system administration, cybersecurity, and distributed systems. Efficient networking ensures reliable, secure, and fast data transmission across systems worldwide. 11. What is a compiler? A compiler is a program that translates high-level programming code into machine code before execution. It checks syntax errors and optimizes code for performance. Compilers generate executable files that run independently. Examples include GCC and Clang. Unlike interpreters, compilers translate the entire program at once. They improve execution speed because machine code runs directly on hardware. Understanding compilers helps developers write efficient and optimized programs while minimizing runtime errors. 12. What is an interpreter? An interpreter translates and executes code line by line at runtime. Unlike a compiler, it does not produce a separate executable file. Interpreted languages include Python and JavaScript. Interpreters provide immediate error feedback, making debugging easier. However, interpreted programs may run slower than compiled ones. Interpreters are useful for scripting, rapid development, and dynamic applications. Understanding the difference between compilers and interpreters helps in selecting appropriate programming tools. 13. What is artificial intelligence? Artificial intelligence, AI, is the simulation of human intelligence in machines. It enables systems to learn, reason, and make decisions. AI includes machine learning, natural language processing, and robotics. Applications range from recommendation systems to self-driving cars. AI systems analyze large datasets to detect patterns and improve accuracy over time. It enhances automation and efficiency across industries. Ethical considerations and data privacy are important aspects of AI development and deployment. 14. What is cybersecurity? Cybersecurity involves protecting systems, networks, and data from digital attacks. It includes practices like encryption, authentication, and firewall protection. Cyber threats include malware, phishing, and ransomware. Effective cybersecurity ensures confidentiality, integrity, and availability of data. Organizations implement security policies and monitoring systems to prevent breaches. With increasing digitalization, cybersecurity has become critical in safeguarding sensitive information and maintaining user trust in technology systems. 15. What is cloud computing? Cloud computing delivers computing services such as storage, servers, and databases over the internet. It allows users to access resources on demand without managing physical hardware. Cloud models include IaaS, PaaS, and SaaS. Benefits include scalability, cost efficiency, and flexibility. Providers like AWS and Azure offer global infrastructure. Cloud computing supports remote collaboration and high availability. It has transformed modern software development and enterprise IT operations. 16. What is recursion? Recursion is a programming technique where a function calls itself to solve smaller subproblems. It consists of a base case and a recursive case. Recursion simplifies complex problems like factorial calculation and tree traversal. However, improper base conditions can cause infinite loops or stack overflow errors. Recursive solutions often use additional memory due to function call stacks. Understanding recursion improves problem-solving skills and is frequently tested in technical interviews, especially in algorithmic challenges. 17. What is a linked list? A linked list is a linear data structure where elements are stored in nodes connected by pointers. Unlike arrays, linked lists do not require contiguous memory. They allow dynamic memory allocation and efficient insertion or deletion. Types include singly, doubly, and circular linked lists. However, accessing elements is slower compared to arrays because traversal is sequential. Linked lists are widely used in implementing stacks, queues, and memory management systems. 18. What is a stack? A stack is a linear data structure that follows the LIFO, last in, first out principle. Elements are added using push and removed using pop operations. Stacks are used in function calls, expression evaluation, and undo operations. They can be implemented using arrays or linked lists. Overflow and underflow are common stack errors. Stacks help manage recursion through call stacks. Their simple structure makes them efficient for specific algorithmic problems. 19. What is a queue? A queue is a linear data structure that follows FIFO, first in, first out, principle. Elements are inserted at the rear and removed from the front. Queues are used in scheduling, buffering, and breadth-first search algorithms. Types include simple queue, circular queue, and priority queue. They ensure fair processing of tasks. Efficient queue implementation improves system performance in real-time applications and operating systems. 20. What is a tree data structure? A tree is a hierarchical data structure consisting of nodes connected by edges. It has a root node and child nodes forming parent-child relationships. Common types include binary trees and binary search trees. Trees are used in databases, file systems, and searching algorithms. They allow efficient data insertion, deletion, and lookup. Tree traversal methods include inorder, preorder, and postorder. Trees help represent hierarchical relationships clearly. 21. What is a graph? A graph is a nonlinear data structure consisting of vertices and edges. It represents relationships between entities. Graphs can be directed or undirected, weighted or unweighted. They're used in social networks, GPS navigation, and recommendation systems. Algorithms like DFS and BFS operate on graphs. Graph theory is fundamental in solving connectivity and optimization problems. Efficient graph representation improves performance in complex systems. 22. What is software engineering? Software engineering is the systematic approach to designing, developing, testing, and maintaining software systems. It involves methodologies like Agile and Waterfall. The goal is to produce reliable, scalable, and maintainable software. It includes requirement analysis, design, coding, testing, and deployment. Documentation and teamwork are critical components. Software engineering ensures quality assurance and reduces development risks. It combines technical expertise with project management practices. 23. What is machine learning? Machine learning is a subset of AI that enables systems to learn from data without explicit programming. It uses algorithms to identify patterns and make predictions. Types include supervised, unsupervised, and reinforcement learning. Applications include fraud detection, image recognition, and recommendation systems. Machine learning improves accuracy over time with more data. It requires strong knowledge of statistics, programming, and data analysis for effective implementation. 24. What is big data? Big data refers to extremely large data sets that traditional systems cannot process efficiently. It is characterized by volume, velocity, and variety. Technologies like Hadoop and Spark handle big data processing. Organizations analyze big data to gain insights and make informed decisions. It plays a significant role in business intelligence, healthcare analytics, and social media platforms. Efficient data processing ensures better strategic planning. 25. What is blockchain? Blockchain is a distributed ledger technology that records transactions securely across multiple systems. It ensures transparency, immutability, and decentralization. Each block contains transaction data linked cryptographically to the previous block. Blockchain is widely used in cryptocurrencies, supply chain management, and secure data sharing. It reduces the need for intermediaries and enhances trust between parties. Security mechanisms prevent unauthorized changes, making it reliable for digital transactions. Preparing these top 25 computer science interview questions thoroughly will strengthen your technical foundation and improve confidence during interviews. Focus on understanding concepts rather than memorizing answers. Practice coding problems, review core subjects, and stay updated with emerging technologies. Employers look for logical thinking, adaptability, and clear communication skills. By mastering these essential topics, you increase your chances of success in technical interviews and open doors to rewarding career opportunities in the ever-evolving field of computer science.